I did yesterday, and it recorded like the first third of my lecture, and then it decided to stop.
I was like, well,
You get a new computer.
That's what I need to do. So, as a preface, let me just say we're doing motion word problems. They are my favorite word problems. I love motion word problems. And there are 3 scenarios, and we're looking at the first of the 3 scenarios. We have a total distance, right? So typically, you have 2 cars leave same place, and same time, okay? So they leave from the same place. Let's see, wait a minute, hang on a second. Oh, I see, I know, I'm sorry, here we go, sorry. Now I remember how So there's not an arrow there. So they're leaving from this place, right? And we're moving away from each other, right? So they're moving away from each other. This is the car 1, or the motorcycle 1, or the driver 1, and this is the driver 2, right? So if they leave from here, this is where they're leaving, okay? That's the starting point. 1 goes this way, 1 goes the other way. What is the formula going to be? Oh, yes, I do. Really nice pencils, too.
Are they your pie pencils? D1 plus D2.
This,
There's some in that.
Here's your horse. Yes, my horse spaceship. Spaceship? Yes. You're holding it wrong. It's a great lecture.
Alright, so let's have it quiet again. Sorry, guys. Here, put that anyway. This lecture is not working too well. Okay, scenario 1, total distance. We're leaving from this place. One person's going that way, the other person's going that way. What is the formula?
D1 plus D2.
Equals?
D3.
Equals?
Total distance.
Right, so D1 plus D2 has to equal the total distance, right? So I'm going to write that. D1 plus D2 equals total distance. Total distance. All right, does that make sense? They both leave from Santa Fe. One goes to Albuquerque, one goes to Taos, right? One's traveling 30 miles an hour, one's traveling 60 miles an hour. It's clear if the one's going 30 miles an hour is going to travel less distance, right?
Yes.
The one traveling 60 miles an hour is going to travel more distance. But if you add their both distances together, you'll get their total distance that they have traveled, right?
Yeah.
Makes sense. Totally logical. All right, scenario 2. Scenario number 2. All right, make sure I write this right this time. Okay, so same thing, total distance.
Oh, God.
Right? That's total distance. And then now we have this, though. We have 2 people that are madly in love. But they are in different cities, right? Right? And so one's going to go towards the other on her bike as fast as she can, and the other is going to take a plane because she's more in love, right? And right? And the question is, all right, so this is the distance the first person traveled. This is the distance the second person traveled. The question would often be, and they have the total distance. So it might say, how long did it take for them to meet? And so you're going to still need to know that distance 1 plus distance 2
Equals D3.
right? It's the same thing, right? It's just that they're leaving from different places, right? Total distance, right? All right, scenario 3. Scenario 3 won't be on the homework tonight, but I'm going to present it anyway.
Scenario 3.
All right, scenario 3. All right, so we have, how did I draw this? Okay. Trying to think of a great example. All right. Nate leaves Santa Fe.
going 8,000
heading west,
miles an hour.
right? And whatever his distance is, that's going to be D1. Okay?
All right.
But you know what? He forgot to bring his Cheerios. And Denise, being a faithful wife, decides that he needs his healthy Cheerios, right? And so she jumps in a car. She didn't realize it until 2 hours later after he left. But so she jumps in a car. He's going like maybe 20 miles an hour because, you know, Nate, right? And then, sorry, Nate. Okay. He's on his bike, right? He's going 20 miles an hour on his bike. And then she jumps in her little, you know, Toyota Prius, you know, and starts going 10,000 miles an hour.
Wow.
And eventually, would you agree with me that she's going to catch him?
Yeah.
All right. So that's her. That's oops, sorry. That's D2. Sorry. D2.
Yeah, they're both.
So the question would be like, how long would it take before she caught up with him, right? And so, but what would the formula be now? Look at the picture. What would the formula be now?
Equals D2.
Yes, exactly, right?
D2
Right? Even though they're leaving at different times, D1 will equal D2 when they actually, you know, when she actually catches up to him, right?
Slams into it.
So those are our three scenarios. Those are our three scenarios, right? And so we are going to talk mostly about scenario 1 and 2. Okay? We will. 3 is very fun. I love 3s, right? But I gotta present. I can't present it all in one lecture, so we gotta just do it a little bit at a time. So now I'm gonna erase my scenarios.
No.
Are you writing them still? Can you copy from Elizabeth's? Can you show her so that she's got them? Because I have to write the problem down now that we're gonna do. So while I'm writing this problem, I want you guys to write the problem, okay? All right. Let's see, we have to have... all right, here we go. You ready? Liam travels at the top speed, at the top speed of 51 miles per hour.
Not just 50, but 51.
So fast.
In his
Bike mobile.
adorable
Mobile.
Volkswagen Bug.
Oh, it's such a cute bug. And a VM.
Okay.
Volkswagen Beetle.
He is followed.
Oh, that's creepy.
Oh wait, shoot, doggone it. This is the 4 hours later one. What am I doing?
Oh.
Okay, wait.
Gary, what are you doing?
Oh, sorry. I thought I looked at these.
Okay, so let's just do scenario 3.
I don't want it because the homework's all scenario 1 and 2. Sorry. I apologize. All right, let's just crap. Let's get rid of this one. We're gonna start over. Oh my God. Lovely. This is a great lecture. Oh, this is 2 lectures in a row that are just dynamite. That's amazing. Okay.
Dynamite lecture.
That's Lisa. Okay, here we go. All right. So 2 cars. So. Driven illegally by, well, I guess I should stick with
who's
Liam.
driving illegally? Arrest them.
By Liam and
I would never drive illegally.
Liam and Kareem. Right? The 2 people you'd most expect to be driving illegally. No, I'm just kidding. You guys will not do that, right? Driven illegally by Liam and Kareem. Where am I? Leave. Haha. This is the important part. Leave from the same place at the same time. The same place at the same time.
1, 2, 3,
Where am
go.
I? Oh, and travel in opposite directions. And travel
Are they moving at the exact same speed also?
in
That would be convenient.
opposite
Like 2 miles an hour
opposites
each
two
way.
P's, right?
Yeah.
Opposite directions. Okay. If Liam's car,
And they leave from the same time.
well, let's say Liam is traveling 60 miles per hour, and Kareem
8,000.
is
Uh-huh.
traveling
2 miles per hour. 100.
65 miles per hour. After
10 minutes.
how many hours will they be 625 miles per hour?
Well, if
After
he's
how
moving
many
60 miles per hour,
hours
that means he's moving a mile a minute.
Green.
Oh, gosh.
Traveling.
will they be
8,000 miles apart.
625 miles apart?
After
Okay,
10 hours. Yeah.
all right. So let you
After
guys
5
finish
hours.
writing that down.
After 5 hours, they'll be 625 miles apart.
These are so fun to do, you guys. You're gonna love these. They're so
Right?
fun.
Except for when you're writing.
How many?
The answer's 5.
Maybe, I don't know.
5 times 5 is 25.
I don't have the answers down here.
And 5 times 120 is
Maybe, I don't
600.
know.
Then we have 620.
You might be right. Sounds like you figured it out. All right, so I'm going to teach you a process, all right? Because the process is extremely important. The process is extremely important because if you can learn a process that works on simple ones, that process will also work on hard ones, right? Difficult ones. So that's what we're going to look at. So let's read it again. 2 cars driven illegally by Liam and Kareem. By the way, I'm really disappointed in you guys.
Oh, God.
Really disappointed. All right, you leave from the same place at the same time.
Wow.
And you travel in opposite directions, right? If Liam is traveling 60 miles per hour and Kareem is traveling 65 miles per hour, after how many hours will they be 625 miles apart? All right, so with motion problems, sometimes they call these distance problems. And the main formula that you always use, we will also use those scenarios, but the main formula you're going to use to organize your data is this. Distance.
Distance.
Oh, I'm sorry, wait. I'm gonna write
Distance
it.
divided by
Rate
speed.
times time, that's times,
Equals
time
distance.
equals distance. I know you probably, how many people have used this formula before? Yeah, so, several of you should have. I believe Matt did it, didn't he?
Yeah.
Didn't Matt talk about this? All right, but he didn't do them this hard, the ones that we're actually going to be doing. He didn't do them quite this difficult. So you always use a box, okay? Always. Just trust me. Always, always, always. Except for Sal, who does it in his head in 5 seconds and faster than I could have done it, right? But use a box. The box will help a lot because, Sal, when they get harder, you won't be able to do that. Trust me, right? The harder ones, you need the box. And so, watch this. We're going to do this. We have 2 people, right? It's just 2 rows, and we're going to have 3 columns. We have rate, and you always write above it, you write this. Rate times time equals distance. Or you could just write R times T equals V, however you want to do it, right? To save time. You don't have to do the whole word. But rate times time equals distance. You're going to have 2 rows because there's 2 people. 2 cars. There's Liam and Kareem. So I'm going to write Liam, and I'm going to write Kareem.
L and K.
Okay? And now I plug in everything that I've been given. And I'm also going to put a little box down here. This is good for scenario 1 and scenario 2.
So the time is X, right?
Okay. This little box is for the total distance that they've driven, right? So now let's see, where are we? So we've got 2 cars driven. Okay, so we got Liam. How fast is Liam going? What's his rate? His rate is 60 miles per hour. Where do I put that in the box?
Right there under rate.
Right here, right?
Oh, gosh,
so I'm going to put 60.
I put it under.
All right, and then it says Cream is traveling 65 miles per hour.
So
And it was in a 60 mile an hour zone, Cream. The speed limit was 60 by
Go 5 miles over the speed limit.
No, the speed limit was
the speed
55.
limit was 50.
Or 55.
Oh,
No,
then you're both, okay, both. Not only are you illegally driving the car, but you're driving it illegally.
No, you can drive
drive
5
Right.
miles.
So, all right,
Underage.
so we figured out the rate, right? The rate. So this is where it gets tricky. This is where you have to use some logic. Do we know the time?
No.
No. Now they left at the same time, right? So the clock started ticking as soon as they left, right? And then as soon as they got, the question is, where's the question? After how many hours will they be 625 miles apart? Would you agree with me if they left at the same time, by the time they get 625 miles apart, that's at the same time too,
Yeah.
right?
Yeah. No.
So-
Yeah.
So the time is unknown, but the time is the same for both of them.
So it's X for both of them.
So it's X for both of them. Does that make sense?
Yeah.
Yeah.
Does that make sense?
Yeah.
Right? So the time is X. And it's for both of them because they left at the same time and they finished at the same time because that's when they got 625 miles apart,
Is
right?
this going to be like, are there going to be 2 equations and we're going to have to like solve them?
All right, so well, yeah, no. There'll be 1 equation from this information. So once you have plugged in what you've been given, what's the last thing we have?
Your distance.
625 miles apart. Let's put that down here.
Oh my.
Okay? Now,
Oh my.
remember this formula. Rate
Times time.
times time equals distance. Do we know distance?
No.
No, so is
Well,
that
we
like
do.
y?
We do. Because we know the rate and the time. The rate is 60 and the time is x. It's 60 times x or 60x. So your distance is 60x. You just multiply this out. Boom. What's the distance here?
65x.
65x. Okay. Now this is scenario 1. What did we say with scenario 1?
60, D1 plus D2.
This is your D1, right? These are distances. This is your distance 1.
Do we
This
add
is
them?
your distance 2.
Yeah, equals total
And this
distance.
is your total distance, right?
So 105.
So wait, slow up. 60x plus 65x equals your total distance. Does that make sense? So usually you're going to use this column, the distance column, to solve these. Not always, but usually. Yeah, usually. I don't know. Probably always. I don't know.
Equals 5.
60x. So we're doing D1 plus
60x
D1 plus D2 equals total distance, right? So 60x plus 65x is equal to 625, right? So that is 125, am I right? 125x is equal to 625. So what's x? What do? I divide by 125, right?
Yep.
Divide by 125.
That's 5.
And
Yeah, that's
son of a gun,
It's 5.
Sal is amazing because 5 times 125 is 625. So x is 5. So am I done?
Yeah.
No,
No, I'm not done. Why?
because you need to multiply.
We have to say it in real hours,
both
in
of
real
them.
words.
Yeah, so I go back. I said x equals 5. I'm going to go back to my box. My box is really valuable. And I'm going to say, well, what did I just solve for? I solved for time. So it took them 5 what?
Hours.
How do you know it was hours and not seconds?
Because it says it up there. It says how many hours will it be.
Right, and what else?
And it's miles per hour.
It's miles
not
per
miles
hour. It's not
second.
miles per second, right? It's miles per hour. So we know it's hours, right? So we said 5 hours. So now, let's be sure that's the question. After how many hours will they be 625 miles apart? That's awesome. So that means we have to put it in words because they asked us in words. So after I'm gonna, okay, they will be.
Hours.
Well, I'll just say this. After, this is fine. You can just say after 5 hours.
I thought some said 10 hours.
We'll just do that. You got 10 hours? Oh no, because you don't add them together.
No, I thought Sal said 5 hours.
No, I did say 5 hours.
Yeah, he said 5. So the answer is after 5 hours.
Well,
Now, so that's how they work. Do you want me to do one more?
no. Yeah.
Does it make
No,
sense?
give us some homework.
No, Salvador can have extra, but we should get it.
We should do math soccer.
No, finish our homework. Yes, we should get our homework and then do math.
So let's just talk about the other scenario, scenario 2, for just a second.
Give us a new problem.
I'm not going to give you another problem. I'm just going to say, let's say these two cars, Liam.
This scenario is your scenario one.
This I'm kind of reframing. Guys, I need a quiet. I'm reframing this into scenario 2 for just a second. Let's say Liam is in Albuquerque and Kareem is in Santa Fe, and they decide to drive towards each other, right?
What if they crash?
Liam at 65 miles per hour, Kareem at 65 miles per hour. Same thing, right? And the question would be, if they are 625 miles apart, which is a very too far for Albuquerque to Santa Fe, but whatever. Well, we'll make you Las Cruces, okay? So you're in Las Cruces, so somebody is. Liam's in Las Cruces, right? And so you're traveling towards each other, you're 625 miles apart. You're going to still put the same thing, right? Because Liam's rate was 60 miles per hour. Kareem's was 65. Notice they left at different places, but they left at the same time.
So it's
And then when they crashed into each other, right? They crashed at the same time.
So it's still 5
So
hours.
the x is still the same. The time is still the same. Scenario C3 is where the time is going to be different. And so we're going to have to take that
Scenario
out.
2, 5 hours.
So it's the same for both.
So it's the same thing for scenario 1 and scenario 2. Okay, does that make sense? And I think all of the homework, I believe, is our scenario 1 and scenario 2.
Back to back or just one side?
Back to back. I mean, 2 sides. And some of you are featured in this.
Do I get to drive illegally?
You didn't get to drive illegally, but you did. You did get to drive a motorcycle. Okay. And everybody will get in them eventually. We've got several of these to do, a few days worth of these, so everybody will be starring in them.
I give up.
So go ahead and get started now and see if you can finish.
We should play math soccer.
We're mad at each other!
So guys, we have to keep it quiet. Guys, hey. This is my class. It has to be quiet, right? You can whisper, talk really soft, loud yelling.
I decided I don't know why you
What?
Let's work together, all 55.
You don't like it.
Gary, next time you have to put a mica in one of them. Okay?
It's a distance runner.
You know?
I don't know why I tried to get her first. I was going to burn myself. I thought they were trying to
Oh, I didn't stop this.